Hey guys, this is part 2 of our mediation bootstrapping tutorials, and in this one we're going to cover how to do moderated mediation. So I've already done all the data screening, which matches the previous work that we did in part 1, which is mediation only. This sort of adds to that and talks about how to add moderator effect to your traditional mediation. So what we're really doing is looking at this particular conceptual diagram. So this is the templates PDF that comes with process that shows you all the different possible options. So this is actually model 5. I just think it's a great picture to show you what we're going to be working on. So we think that there's some sort of mediation between X and Y, given by M here, but that there's an interactive effect of W on the C path. Now we could add this moderation in any of these paths, but very specifically we're going to look at C here. And if you scroll through the different templates, it goes through pretty much every possible combination that you could want with several moderators and moderation on each individual path and moderation on each combination of these paths. But today I'm just going to focus on how to do this on C. And so what I'm going to start with is after I do my data screening, so I've checked all my variables and come up with outliers, that sort of thing, I'm going to now scale or center my continuous variables. So remember, when you do moderation, one of the most common things you want to do is mean centering variables, which is what also process in SPSS does. Because otherwise you're creating multicollinearity by including the interaction between the variables. And so I'm going to scale them to help with that multicollinearity. Now you can do z-score scaling, but I don't recommend it because mean centering is not only more common, but it also doesn't really mess with the variance. It just moves the whole distribution to plop right down where the middle is 0. That aids in interpretation as well. So we're just going to mean center. By doing that, we're going to use the scale function. The scale function without any extra pieces will do z-scoring. I put scale equals false because I don't want to divide by the standard deviation. Center equals true will give you the mean. We will subtract the mean from everything. So I'm going to center my X and my W. Okay. I'm not going to center M because it is not part of the interaction. So M is not included in the interaction, so no need to center that. If you have your interaction on the A path here, you still wouldn't need to center M. If you have it over here on B, you would need to center M and W. So you have to see what variables are part of the interaction to know which ones to center. All right, so we're going to start with the C path, and we're actually going to look at the C path. If you look at the output from process, you don't see the C path. And so I don't think it hurts to look at it, but given that this is a moderated mediation, a lot of times people will kind of ignore C here. But we could look at whether or not X even predicts Y. So kind of depending on your feelings on mediation, which you should go back and watch the original video, you may require that X predicts Y to start, or what is mediating what. And so you could look here at what's happening with the moderation, but we're really going to be interested in another piece of this to talk about if there's moderated mediation. But I can see that X predicts Y and W predicts Y, but there's actually no interaction just yet. But traditionally, this is not something you'll see in the output, but I don't think it hurts to look at. We're really more interested in the interaction of the mediation. So I'm going to look at A here, and I need X to predict M. And this is the same example that I gave in the previous video, so clearly X predicts M, which implies that it does have a path from X to M. Now let's see if there's a path from M to Y, which is going to give us the B path. But at the same time, we're going to include X. And because I'm including X, I am also including my W, because I'm really interested in this interaction of X and W predicting Y. So is my B path significant? Does M predict Y? And the answer is yes. X is diminished here from the beginning. So I went from 20 to 0.06, but really we're more interested in our interaction. Now the interaction here is actually not significant, but for the purposes of teaching you how to work this particular example, we're going to continue, but here it's not significant path change. Now, from here, what I want to do is figure out the simple slopes. Now, simple slopes are where we're looking at people's scores who are low for our moderator and who are high for our moderator. Here, in this output, we get the average score. So the nice thing about centering and putting everything on top of 0 by subtracting the mean from all the scores is that this creates an average effect here. And so I'm really interested in looking at x. So what happens to x when I move y around? I'm sorry, not y, w. And so you always have one variable that I sometimes call the flip variable, but really it's the variable that you want to see each slope. And that's going to be w in this particular case. So you got to pick one to be the moderator. And so I'm going to get low, average, and high. I've already got average. And so because I'm separating those out, I want to look at the other variable. So you have one that you flip and one that you check. And so we know at an average level of w, x predicts y at 0.06. But then we got to throw in the mediations. This gets a little more complicated. Now, what happens when at a low level of w and a high level of w? And this is where immediately lots of people's brains just like short out. The way that you create low and high levels for the w variable is backwards. And so here's how I always think about this. You think about the middle of a distribution. Okay? And right now it's centered over the average. If I want to know what happens for people at the low end of the scale, my periscope or my vision is only for the middle of the distribution. So I have to take everyone who's on the low end and shift them up. So now that they're in the middle of the distribution and I can look at them. It's very tempting to think, especially when you have a program that does this for you. So like QuantSci has a nice package that'll do this for you. And Process is a nice version of SPSS that'll do this for you. It's very tempting to think that it's creating low, average, and high groups. So it's just like splitting them into thirds somehow. And that is not what is happening at all. For the average slope, what happens is that we're just looking at the middle of the distribution and people who are at 0 are on the average. For the low, we shift everyone, the entire data set, up to the middle and see what happens to them. For the high group, we shift them down now to the middle and see what happens to them. So we're shifting the distribution around of W here and seeing what happens to X. So we're just kind of like moving that data set up and down. And that is okay mathematically because a linear transform of a variable doesn't really change the results for the other variables. It will change X, but it won't change W or the interaction. If those numbers are changing, you're doing something wrong. Okay. So what we're going to see is that W here and the interaction will stay the same. X is going to move around. Okay. So we're going to create our low group by shifting them up. So I'm adding a standard deviation to them to move them up. Create our high group here by shifting them down, and I'm going to subtract a standard deviation to move them down. I think that's the hardest thing conceptually to get about moderation when you're doing it by hand, is that you would think the low group is one standard deviation below the mean, but to create them, you have to move them up to the middle where you can see them. So if you think about being like seeing something like having blinders on or having blind spots in your car, you have to shift the low people to the middle to see them, which means you have to move them up. You have to shift the high people to the middle so you can see them, which means you have to bring them down to the rest of us. So now we want to see what happens to the C prime paths at these low and high demarcations. Let me make this just a little bit bigger. Here we go. And so what I'm going to do is run that B path thing again, but this time put in the low centered W variable and then the high centered W variable. And if I'm doing this correctly, my other variables over here won't change. So let's look at low here. So my C variable for that, my C prime path is 0.08, 0.09. I'm going to look at my summary of the original statistic, which is the average group. And C prime here is 0.06. CW is 0.51, and it's also 0.51 here. So I'm doing things right because the other things haven't changed. The only thing that should be moving around other than the intercept is the variable that's the other half of the moderation. So we are flipping, moving around W, seeing what happens to X. Okay. So we went from 0.09 to 0.06. And then for the last group, the high group, we went down to 0.04. Okay. So what's happening is, like, as W is going up, X is decreasing. Okay. So as W goes from low to average to high, X is going from 0.09 to 0.06 to 0.04. It's decreasing. Okay. That's actually not a significant interaction because my interaction is not significant here in the main effects model, in the main model. Don't say main effects. So my interaction isn't significant here, but so 0.09 to 0.06 to 0.04 isn't a significant difference between these slopes. But that's kind of the pattern that we'd expect. We'd expect them to be kind of creating this fan effect where they're changing across different levels of W. Okay. So I wouldn't argue that this was a significant moderation at all because there is no interaction effect, but this is how you would analyze it if your interaction was significant. Now, if I was interested in the Sobel test, the way the Sobel test works, and one thing I really like about this template here for Hayes' process model is that it very nicely tells you like what the indirect effect is, how it's calculated. So we can get into these models with three mediators and a moderator can get really tricky. So he's laid out very nicely the way to calculate an indirect effect, right? And then the conditional direct effects as well. But mostly we're interested in this indirect effect. And that is going to be the A path, which is X predicting M, and the B path, M predicting Y, and that has not changed this entire time. And so that's how I pulled it. I just pulled these from these coefficients, right? So the A path is X predicting M. Let me back up a second, right? And so that's this 0.49 thing. Now the M path, C prime path, or B, the path for M, is M predicting Y, and that's this 0.68. I'm just using the R code here to pull those specific numbers. So X predicting M, M predicting Y. Because the mediation effect, or the indirect effect, is A times B. So I pulled A and B. I'm now going to pull their standard errors. This z-score test is this version of Sobel. I have no idea how to say this. And it's slightly different than the version of Sobel that Process is using, but we'll get a pretty similar answer. So we get that our mediation effect is 13, which is a z-score of a very, very tiny p-value. But I know that Sobel is not super popular. It's kind of losing popularity. So what we're going to do instead is bootstrap that mediation effect. So I calculated my indirect effect by multiplying A times B, and that gives me 0.34. So including that moderator has actually changed our indirect effect. If you watched the first video, that indirect effect was a lot higher. It was 0.50. So would I argue that there's moderated mediation? Well, it appears to be mediation at the very minimum because our Sobel test is significant, and as you'll see here in a minute when we run the bootstrapping will be greater than 0. I think it would be hard to argue that there's moderated mediation because the interaction is not significant. Okay. So I would say this is mediation. The moderation doesn't appear to be there. But this is a video on how to test this. So if this were significant, I would say yes, there's moderated mediation. I would talk about my 3 simple slopes, my simple C prime paths, and then I would talk about the indirect effect and its bootstrapped confidence interval. And here's how you get that. Okay, so remember, if you watch the last one, which you should totally do first because I explained these boot library a little better, is that we saved a function. So when you create, or you're trying to use the boot library and the boot function, you have to create yourself a function that gives you the statistic that you're interested in. And so the first argument for that function needs to be the name of the data set. And I've just got a placeholder here called data set. I'll actually define which data set I want here in a minute. And then you need to have a randomizing section. So part of bootstrapping is to randomly pull from the data set, so it needs a way to randomize. Because if you don't randomize, this will not work, because that is the biggest struggle I had learning this. And then within my function, I'm just telling it to randomize by row. So randomly pull people by row, not by column. That doesn't make sense here. I'm going to pull by row. Okay. And so remember, it's rows, comma, columns. So I'm creating a data set, a randomized data set. Now I'm going to run A and B. A and B here only run on the average effect. If you should get the same effect really if you run it on low or high, because remember, nothing else is changing. The A path and B path don't change. It's the X to M C prime path that's changing. So creating this indirect effect in this particular moderated mediation does not involve 3 different indirect effects. So we're going to calculate that and tell it to return that indirect effect. I'm going to load the boot library. That should be in base R, but if you don't have it, the library is just boot. The boot function, the first thing you're going to define is which data set you want to use. So I'm going to use my no out data set. The statistic here is this function that we wrote. And then R is the number of times you want to bootstrap. I'm only running 1,000 because my computer, otherwise we could all go take a nap while it ran 5,000, but 5,000 is the default in SPSS. All right, so we got our boot results. Let's see. We should get our original indirect effect path back. So that's what I got here. It gives you a little bit of information about that effect. So sometimes people report the standard error. I'm more interested in the confidence interval though, so we're going to do boot.ci of our boot results and a 95% normal confidence interval. So our confidence interval for our indirect effect in this particular case is 0.3 to 0.37, which does not cross 0. So I would argue for mediation in this case. So you can either believe Sobel, or you can believe that this confidence interval doesn't cross 0, or you can include both and make everybody happy. And then even though we haven't really looked at C, right? You won't see necessarily, sometimes people won't report C. It does appear that C to C prime has decreased, closer to 0. What I'm going to do now is I'm going to write out this data set. And open this up in SPSS. 2 shakes, I forgot to log in to my university server. Now let's look at this in the process model plugin and show you that it's approximately the same thing. while we wait 8 years for SPSS to open. Okay, I don't know what this is doing in the background, but we're going to, oh, I may have written that file out before. Or I could crash SPSS, that's cool too. This is why I do not love working with this program sometimes. Let's see if we can convince this to work. We'll just hide that back there. Good grief. Great. Now that we've got the data set pulled up here, one thing that it did was it also exported my centered variables and my two low and high variables here, but that's all going to be created for us by process. So I'm going to click Analyze, Regression, Process. We're going to pick Model 5 because that's the one we're interested in. So always compare to your template to the template document here. It comes with the download for the macro, and it will really help you figure out which variables you have to stick in which box. Because if you try to run this model without W or you stick it in V, it's not going to work. So we're going to Model 5 here. Our dependent outcome variable is Y. M for the moderator, X for our independent variable, and W down here. I'm going to kind of leave all this stuff alone. I'm going to click mean center for products, heteroscedastic consistent standard errors, and then basically none of the rest of this is available to us. And I don't have any of these other options. Now I could click conditioning, but this is the default that we want, and Johnson-Neyman's not going to run because I have Model 5. Alright, you're going to do your thing. Alright, having some issues with SPSS today. Okay. So let's scroll up and look at what's happening here. So we don't see C. It doesn't give us that path, but it does give us X to M, right, which is the A path, 0.4925. That matches our other output. It should also give us all of the information for C prime here, 0.606. B, which is M predicting Y, which is 0.68. Our main effect of W predicting Y. And then the interaction, which is not significant, so 0.059. Now this matches everything that we had gotten out of our B-path model. Oops, sorry, let me do the average B-path model. Okay. So none of this is significant. Maybe our p-values are just slightly different, but that might be a number of decimals issue. Now, it's going to give us the conditional direct effects of X on Y. Right? So this is each little C prime path given at different levels of W. And you'll see that at the low level of W, which is this negative 0.384, I got 0.0878, right, which was our summary of the low path, 0.087. It would be 8 if I rounded up to 4 decimals. our average level, which is 0.6065, which we've already seen here, and our high, which is 0.04. So this matches what we were able to do using mean centering in R. And the big thing here, this indirect effect of x on y, which is the mediation component, because there's no Sobel, it's 0.3373. And so that should match. Go away. Okay. So 0.3373 if I round up. And then let's look again at our boot confidence interval. I got 0.301 and 0.373. And this is 0.3034 and 0.3724. So very close. And it'd probably be even more close to these numbers if I, in R, ran this 5,000 times, which is what I would do probably if I were doing this for real publication, because 5,000 seems about standard. But to save you all some time from sitting here waiting on my computer, I just did 1,000. So you're getting a very similar picture to what is presented in this plugin in SPSS if you're an R person. And even the standard error is very similar. So our standard error of our bootstrap, which we can get by just running boot results, right, is 0.018. And the standard error over here is 0.018 if I round up. So very similar results. The trickiest part about doing this in R is just figuring out how to do the bootstrap function and learning how to create this function for your statistic here. So you can take this code, which is going to be on our advanced statistics page here in a couple minutes, and use it to edit. You can put the interaction on any one of these paths. It does get a little bit more complicated if you're going to put the interaction in multiple paths. But that's where I really tell you to look at some of these templates, because the plugin is free. Even if you aren't going to use it, you can download this PDF. And look at these interactive, once you get past the 6 bazillion versions of mediation, look at these different pathways and just make sure you're calculating your conditional effect correctly. So for this particular one, you might have to calculate one for each slope. And so that's going to be where it gets tricky, is when you have these multiple interactive paths. But you can take the code that I've already written and sort of apply that to be able to get these conditional indirect effects to see if you have moderated mediation.